Hello, guys. Good morning. My name is Ricardo Buranello. I'm Vice President for Talit, the division of our industrial solutions, and it's a pleasure to be here talking to you today. Um, I'll wait just a few more minutes, one more minute, so we can start our webinar. Okay, so let's get started here. Um, I don't know if all of you here in this call knows Talit, so let me start with a very brief introduction in terms of who Telit is. Telit's a global company. We're traded in London Stock Exchange, and basically the only thing that we do is IoT. It is really impressive that today Telit is connecting one new machine, one new PLC, one new CNC, one new smart meter, one new smart IoT device, basically every second. So for everyone that thinks that IoT is the future, uh, this is a very strong message that no, IoT is the present, and IoT definitely is one of the major forces that will reshape the economy and how things are manufactured. And it's a pleasure for me to share a little bit of my view in terms of how this technology will really reshape the world. Talking a little bit about Telit, we are divided in three main business units. The first one is what we call the IoT modules. So think Telit as, I would say, the Intel of Internet of Things. We produce semiconductors, chips, millions and millions of chips that goes inside different types of devices that we will use IoT connectivity, such as cellular connectivity. So these chips, they go inside gateways, industrial gateways, different types of equipment, even cars and different types of devices that will use different types of technologies to communicate data. When you were thinking in terms of typical IoT highly distributed scenario where things are connected everywhere, having cellular connectivity is an important technology. And then Telit has a global MVNO, so we have our own SIM cards with data packages for IoT. And we have our software and platforms division. This is where I'm in, and this is a little bit of the technology that I will show you here, and I will discuss in terms of how this industrial IoT technologies are reshaping manufacturing. We started the development of our technology basically 20 years ago inside IBM Automation Group. In 2013, Telit acquired a spin-off of IBM Automation Group, a company called ILS Technology, and then we bring into our product portfolio our industrial IoT platform called DeviceWise. DeviceWise is becoming the major player in industrial IoT. Just as a brief reference here, the 7 out of the 10 biggest car makers in the world, they use DeviceWise for their IoT platform. 10 out of the 20 biggest tier 1 OEMs in the world, they use DeviceWise as the platform. And we have our technology spread in all the different sectors, from automotive to pharmaceutical to oil and gas to machinery. So basically, everywhere that you have the necessity of collecting data, analyzing data, taking decisions out of this data, DeviceWise is something that can be applied. But first of all, why industrial IoT will be so transformative in terms of the manufacturing space? I really like a lot There's a statement from Paul Krugman that he says productivity isn't everything, but in the long run, it is almost everything. Basically, uh, 20 years ago, most of the big companies, they decided that to survive they had to go to low labor economies, so they started manufacturing their goods far away from their main markets. They started manufacturing their goods where they could have economy of scale and they could reduce the labor costs that they had, so that the amount of things manufactured in the West, in Europe, in the United States, in Canada, significantly reduced. What is happening now, and even this incredible situation that we are going through of coronavirus, but not only this, as well as all the tensions of the trade war between China and United States, makes many companies to rethink the way that they are manufacturing and that they will manufacture in the future. There is a huge wave of technology that will have an impact to make the companies more productive. And this is Industry 4.0 and IoT. The correct application of the technology will significantly bring competitive advantages for the companies. And the companies that will survive for the next 5, 10, 20 years are no longer the ones that are able to produce far away from their markets in economies where the average salary is low, but the ones that will have the ability to apply the technology correctly and getting the competitive advantage out of this technology. McKinsey produced a very, very interesting report approaching all the different aspects of IoT. And if you are a person like me that believes that IoT is something that came to stay, and that yes, probably every single car will be connected in the world, can you imagine about a PLC, about a machine that is running lines producing millions and millions of goods, that one stop of that machine can represent thousands, dozens of thousands, sometimes even hundreds of thousands of dollars per minute, per couple of minutes. So the impact, the economic impact of IoT is happens mainly in industrial applications. The same report from McKinsey, they highlight that there are many ways for you to optimize your costs and your productivity by using IoT, and that some of them, such as operations optimization and predictive maintenance, has the potential gain of reducing from 5 to 40% the costs of the operations. That's a huge impact. And it's no longer a decision for the companies if they will apply this type of technology, but it's kind of a must to survive in this new world that we apply this technology in an efficient way and we can bring these gains of productions to our own companies. So let's talk a little bit here about what is IoT at the end of the day. This is a very generic term. We must assume that, it's very hard to say, is this IoT? This is not IoT. So let me give you my personal view in terms of what IoT is. Here, I put a picture of a non-IoT factory. As you can see, it's a factory as the ones that you guys work or the ones that you guys provide services for. Uh, just a natural factory, right? I can see a couple of machines here. I can see some people. It's a big space. Definitely not an IoT factory. And here is a picture of an IoT factory. Very different? No, not at all. Exactly the same factory. Exactly the same thing. What makes this factory to be a real IoT factory? Let's take a deeper look on this. When an IoT factory, basically you have what you have in every single factory. You have different controllers moving the parts around, controlling the machines. You might have, as in this picture here, one Rockwell controller controlling that crane over there. A Siemens CNC controlling that machine cutting metal. Maybe a Siemens PLC here in this other machine being controlled by this person. That's an AGV moving parts in between the lines, and I can see a nice orange robot on my right hand side. Still, this doesn't make an IoT factory. When I start thinking in terms of the IT department of this factory, what I realize is that yes, this company has different types of ERP systems, MES systems, different types of databases, some types of report tooling, as well as they have cognitive clouds, as in this example here, they are using Watson. What makes this factory IoT is not the ERP from SAP, the database from Oracle, or even the incredible tool from IBM. What makes this factory an IoT is your ability to interconnect all the different things, all the different devices, all the different manufacturing components that you have to your different IT components in a completely transparent way. This is our personal view of industrial IoT. This is how the companies will really get the most of their productivity by making sure that all the different machines that they have, the new ones and the old ones, they are operating at the maximum capacity possible, as well as that all the different IT systems and components that they have in their data center, in the back office, they are also working flawlessly, completely collecting the data in real time from all the different parts of the manufacturing, processing it, and providing data for managers to take the right decision. One of my brilliant colleagues here in Telit told me one thing yesterday that really made me think. The capacity that the quality of your data analytics is proportional to your capacity of data collection. If you have a good data collection, you can start understanding better your data, taking better decisions, and making sure that your line is working on a more efficient way so you can keep your productivity. Um, Guys, just one very brief comment before I keep going here. I will be if you have any question, please feel free to write here on the chat. At the end of my presentation, I will be replying it to you, okay? So now let's talk a little bit of the transition from Industry 3.0 to Industry 4.0. Uh, in the old Purdue model where you had typically one very hierarchical communications architecture where all the data is coming from the bottom to the up, where basically the machines they just talk the things they you just collect the data that the machine builder predicted you to get this data. You push it up in your hierarchy, making the things my machine communicate to my MES communicate to my ERP, and so on and so forth. The way that we see the future, actually the way that we see the current technology, is that machines are no longer only machines. Machines are data points. All these machines, they need to have the ability to talk to all the different IT systems that you have, but not only the different IT systems that you have, as well as to the different types of machines that you have in the line, so you can integrate a Mitsubishi robot to a Siemens PLC, to a Rockwell PLC, maybe to a DCS or whatever else you have on your shop floor. And this is what we are working to transform into a reality for every single company. That the machines can provide you real-time feedback on what is happening there. And as well as these machines need to be fully integrated in terms of helping you to get a complete transparency for your operations. Well, now that I talked a lot on a very general terms, very broad context, let me start giving you a couple of real cases examples on how companies are using industrial IoT to make their life better. So let me explore a couple of use cases here before I can really show you some real things being done here. The way that we divide IoT is based on two big groups, big types of projects. What I like to call it connected factories or connected machines. For me, these are the two main types of industrial IoT applications, as you can see here divided by this yellow line in between. Let me start talking a little bit about the bottom, about the connected factories. When you are working on the shop floor, the biggest challenge you have on your manufacturing assets on your site, you have different types of hardware provided by different vendors, all of them talking different types of protocols, some of them connected, some of them not connected. You also have different types of tools, not only machines, like torque tools, or different types of tools that people use to perform a certain action. You have different sensors. It can be environmental sensors, as well as it could be vibration sensors, presence sensors, visual inspection sensors, different types of hardware there. And basically what you have is different islands of information on your left-hand side here. On your right-hand side, your IT has different types of systems and databases, everyone running one specific action, but not fully integrated. Having the ability to integrate all the different systems and all the different machines is basically what will make your line more productive. So what you need is to have one transparent layer of communication, accessing all the data from your devices to all your systems, and having a complete automation of decision of data delivery in this between. You have HMIs, and it's more and more common that companies have uh, open clouds such as Microsoft Azure, Amazon AWS, IBM Watson, Google Cloud Platform, Siemens MindSphere, and others. So basically, what DeviceWise does, what our product does, and what we are doing for our customers is helping these customers on having all these assets connected inside the four walls, pushing to the IT system, and having this complete integration. But you also can think in terms of the connected machine environment. On the connected machine, I like giving an example of a car wash machine. A car wash machine is nothing other than PLCs and robots moving parts, spraying water and soap to get your car clean. The difference is that different from one typical factory, a car wash machine typically is distributed in hundreds, if not thousands, of gas stations all around the world. Having the ability to collect the data from this machine that is very far away from my site is a big challenge because this can be a game changer for you to make your operation more productive. With DeviceWise, we can run not only on a Windows or Linux computer as we run on the connected factories, but we also can run on cellular gateways. So we have the ability also to connect the machines that are not necessarily on your site. Having the connectivity to this machine allow me to open tunnel and having the access to my device, doing the setup and the maintenance of my device as if I were in front of the machine, but in a completely remote way, as well as collecting real-time data from the performance of my machine for predictive maintenance, preventive maintenance, operations controls, and much more. So with the current technology, things can be completely connected if they are on the same site or if they are far away. In this example here that I will talk a little bit, this customer that we have is a very, very large customer, the largest electronic producer in the world. The biggest challenge that this company had was having the ability of control the real productivity of their line. In this specific line, they are producing ink cartridges. The ink cartridge production line is an extremely fast production line, where if you have any sort of latency on your data collection, it will completely compromise your ability of having the data, quality data, for you to really know if my production batch is running well or not, if my machine is about to break or not. So this company tried to hire three other companies, three other technology providers, and all of them failed miserably in terms of doing this complete OEE application. Intellit, we were able to do this full project from the beginning to the end in less than 3 weeks. Having the ability of reading data in real time from different types of machines using the native protocols, not only open protocols such as OPC, Modbus, MT-Connect, or any other type of common open protocol that you have, is a big game changer on our technology. We can collect data in real time, in milliseconds. So now we provide to this company the ability of knowing exactly what is the productivity line by line, shift by shift, operator by operator, providing them the ability to see if they are going to reach or not their targets, their objectives, as well as start identifying things that are start to go out of the norm, starting to get out of the spec. So people should go and take a look before the machine breaks or before I get a significant reduction in my throughput of the line. Uh, so this is a very typical example where we can use the IoT technology fully deployed on-prem to collect the data in real time from the machines, doing calculations of what is the efficiency of every single machine, creating digital twins, as you can see in this small dashboard on the up right side of my screen. So you have the real-time feedback from all your machines. Now this data is available for them to see in this nice control room that they have, as well as in tablets and phones while people are in the line. Not only this, DeviceWise can sense extreme situations and then send alerts through emails, SMS, or popping up in these screens so people know in real time what is the performance of their line. At the end of the day, you just can improve what you can measure. So this is what we really can provide to companies by collecting this data, analyzing this data, and doing this complete end-to-end deployments. Very interesting project, right? Now let me talk about a completely different type of application. For this customer here, this is one of the biggest automation companies in the world, and they use DeviceWise to have access to remote data from all the machines that they sell to the market. This company is selling, it's a Japanese company, and they are selling, in this specific division, laser cutting machines. These laser cutting machines, they have controllers inside, but the challenge that the company had was these machines were spread all around the world. Hundreds and hundreds of customers that they buy this machine that is not a cheap one. It can cost you $700, $1,000, $1,000,000 each laser machine. But you know, when you have a high investment like that, you want to make sure that your machines is running on a very efficient way. On the other hand, the objective of the OEM was having the ability to receive real-time feedback from the products that they deployed in the field so they can have happier customers, and they also can provide a better support for their customers by having the remote access to these machines and helping them on the setup and then the maintenance of this device. As well as they want to have the ability to sense when a certain part of this machine needs to be replaced so they can proactively approach their customers before the machine breaks, telling them that they should go on a predictive or on a preventive maintenance out of this platform. The way that we created this application was by using the capacity of our cloud architecture, where we have DeviceWise running inside gateways, collecting the data in real time from these machines. When you have the data available in real time inside the four walls, as you can see here on the bottom left on the plant one, I have the ability of making this laser cutting machine a smart laser cutting machine. So now this laser cutting machine can tell my ERP, my MES, what is my productivity, provide data to local databases, but also push the data into the cloud. So now technicians, engineers that might be anywhere in the world, maybe in California, maybe in Chicago, maybe in Japan, having the access to this laser cutting machine that might be in Mexico today without having the necessity of jumping into an airplane on a fully connected machine with all the layers of security needed for that. On top of that, DeviceWise provides all the data visualization out of your devices so customers can also know what is the performance of their machines in real time, doesn't matter where they are. Even in a terrible quarantine moment that we are living now, I can just open my cell phone and see if my line is running properly or not without being in front of this device. Well, two very interesting and two very different projects, right? One that is everything inside the four walls. I have multiple parts of machines and I want to make sure that my line is running as efficiently as possible. The other one is a highly distributed scenario where I have hundreds of customers using my machines and I want to improve the performance of my machines and I want to improve my services by having remote connectivity. How can these projects be deployed fast enough on a quality way? And here is the secret sauce. Basically, what we provide in the technology we provide, and now I will enter a little bit more explaining you how we do this. Projects like this can truly be deployed in just a few weeks. And the reason for that is that we have been spending the last 20 years developing something to be plug and play, to be easily configurable for you to start this IoT journey. The way that companies are doing it today is by having tons and tons of custom code. They basically, uh, when the the way the world is today, if a certain company needs to have data connectivity from a machine, typically how they start, they call the IT or the OT department, that they start writing one driver to have the data from that machine, and then they write one custom code software to push this data into somewhere else, and then they write another custom code software to push this data from somewhere else to one application that will bring any type of result to this company. What happens is this is super expensive and not efficient. Think that all these companies are reinventing the wheel every time that they enter in a project like this. That was how IoT, that was how machine connectivity was done in the past. The reality is that now that we have very advanced platforms, we need to have a standard way that is proven, that is scalable, that is repeatable, done. And this is basically what we do for a living. DeviceWise is the best platform of the market that makes any machine to communicate to any type of system. The way that we do it is having the ability of using DeviceWise to push data from all different types of sensors and instrumentations inside PLCs, CNCs, robots, and from there to all the different types of systems that the companies have, doing this complete integration. So DeviceWise is a software. It can be installed in any server, Windows, Linux, big mainframes such as IBM AIX platforms, even the backplane of PLCs, as well as cellular gateways. It comes with three main pillars. One that we call device access layer. So DeviceWise comes with hundreds of drivers for you just to click, appoint, and use, as I'm going to show you here. As well as it comes with an edge logic engine that you can transform this data, you can create expressions, you can do inserts in databases, you can do all your magic, all your data logistics without writing one single line of code. And it comes with all the different IT connectors. If you're using Oracle, we can feed your databases or your Oracle EBS or whatever Oracle Suite platform you're using. If you're using SAP, we can push data into SAP. If you're using AWS, we can push the data into AWS. If you need to have this data in historians, we can push this data to historians, and everything on a completely bi-directional way. Um, Device-wise, as I said, comes with all the different drivers for you just to click and download. All the list of drivers are available at the internet, and I will show you here a few examples as well as the connectors. Here is just one snapshot of our Edge Logic engine, and I will show you a little bit more. But this significantly reduces the time it takes for you to write any type of application by having the ability of just drag and drop blocks of logic and defining what you're going to do with your devices. And we have something that is brand new that I will even show you a little bit here, that is your ability of doing a drag and drop data visualization. DeviceWise also comes with a dashboard builder that you can create your own on-prem charts, HMIs, reports, such as these nice ones that I'm showing you here. You can calculate your machine's performance and display in live and colorful displays. As this is, you just need to have a web client, you can do this in browsers. So you can see this in any type of browser, in your computer, to big screens across your line, to mobile devices. Not only you can show the data into this place, but you also can do this on a bidirectional way. So imagine, for example, if you were putting one tablet in front of a machine, you can let your operator know what is the performance of his shift, as well as you can make this operator to add data back to the system. So for example, if this machine is down, the operator can give exactly the reason why the machine is down. So now when you run a report of your downtime, not only you know that the machine was down at this hour because DeviceWise is collecting the data from your PLC, as well as you have the reason why this machine was down because I am combining the data from the machine with the data inputted by the operator just using a touchscreen button in a tablet. So DeviceWise is not only a product, it is a platform. By being a platform, I mean that DeviceWise becomes your middleware, your layer in between all your different devices to all your different IT systems. That's good, but what can I do with that? The only reason for this to exist is to solve real life problems. So basically, you can do a complete integration and automation of different types of systems, machines, and etc. So let me give you an example. A couple of months ago, I've been to a customer that produces basically medical devices. In that line that I was, they were producing like the knees and the hips implants for replacement. Basically, what they have is highly precise CNCs cutting metal. The way that they would like to integrate was using one robot to pick up the piece from the CNC, putting on a prober tool, on a quality control system, measuring the part, and they would need to write back the offset on the CNC so they keep the quality of the process. The way the DeviceWise entered in this process was by reading the data in real time from the CNC, letting the robot knows when the process was done, so the robot could take the robotic arm, pick up the part, and place this on a quality control system. DeviceWise was starting the quality control system and reading what was the results of the cutting, doing the calculation of what was the needed offset on the CNC, and writing the data back on the CNC. So basically, in this very simple line of three components, a CNC, a robot, and a quality system, DeviceWise was doing all the logistics, orchestrating how these three equipment were working, not only by reading the data, but taking decisions based on this event stream processing. At the moment that I have all my machines connected, implementing a preventive or predictive maintenance program is just a matter of some extra clicks. I can start from the very basic. I know, for example, that this certain CNC should run for 1,000 cycles, and every 1,000 cycles it should be recalibrated. Now I can just go to device-wise without writing one single line of code and just set up one trigger saying, count how many cycles I ran here, and then open one ticket in my SAP PM. Or write one report at the end of the week of what should be the machines to be recalibrated at the end of this week. And I can integrate this with artificial intelligence platforms so you can have very complex algorithms telling you when this machine is about to break. All this starts with having the quality of the data collection and having the ability of taking these decisions on the fly. We can have, as the example that I gave, your full quality control system implemented, as well as I can start now collecting the data of all these machines and letting my managers know how my shift is working, so I have the complete visualization and traceability of what is my OEE, of what is my efficiency. I can have all the different components integrated without the need of custom code, without the need of wasting my time doing things that are not the core of my operations. As well as I can have any type of cloud, Azure, AWS, Google Cloud Platform, Siemens MindSphere, PTC ThinkWorks, and etc., all connected, receiving data in real time from these machines, processing the things in the cloud, and pushing this data from the cloud back to the machine. So now that I have all my systems integrated, I can use DeviceWise to read in real time my MES system. That could be Dassault Apriso or a Siemens Symmetric IT, and I can understand in DeviceWise what is the next part number to be produced. I can go to a database and I can collect a recipe from my controller and set up the line with zero human interaction. And having this complete line integrated, providing me data in real time for a completely digitized platform. Sounds like magic, right? So let me show you really quickly here, so we still have some time also for the questions on what DeviceWise is. I will open here this system that is what we call the workbench. So basically this is DeviceWise. You will install it in your node, in your computer that will be in your line or in your data center. And now you have the ability of collecting data from all different types of devices. Typically, for you to collect data from devices, it's as simple as clicking New, defining what is the name of the device. I will call this webinar CNC. I will define what is my IP address here. First, let me pick what is my driver. For this one, I know that this CNC that I am connecting through VPN at my office is a FANUC. So I put here, let's see if I have the IP address of my FANUC. I put my IP address of my FANUC. I click validate. Yep, it's validated. I click save, and there we go. I have my machine already connected. Let me start it. It started perfectly. So now I can see all the variables. You saw how easy it was. I said, what is my IP address? I pick my driver out of an extensive list of drivers. These are just a couple of ones that I downloaded here on my computer. And you have many others that you can download from new, old machines from all different types of vendors. And now when I click here and I start seeing my device, I have all my tag tree auto-enumerated for me to read and write. As you can see, all the data is already flowing from my machine into device-wise, so zero code, just having the data here coming in real time. That's great. What can I do with this data? Well, I can define transports. For me to define a transport, for me to define a location where this data is going to be basically as simple as we defined one new device. I can click in new, I can name what is the type of transport that I will use, I can define databases, I can have different types of IT connectors here that I'm gonna use. This is just a couple of ones. You can see here in the in my screen uh, other devices, other transports that I could use, such as Siemens MindSphere, Microsoft Azure, Google, Amazon AWS, Google Cloud Platforms, ThinkWorks, and many others. The way that I will do my projects is by creating real-time applications. On these applications, I can use a fourth generation code method that I don't need to write one single line of code. I will just create a trigger. If you want, I can even create here a trigger for you, just for you to have an idea in terms of how simple it is. DeviceWise also comes with an embedded light SQL database that I can use typically for my logic. I can do here, so let me name this database, and I will call it webinar table. Let's say I will add one column to my webinar table. I will call it time, and I will define that this is going to be my timestamp. I just added one column. I will add a second column, and I will say that the second column is my value. Done. I created a database in DeviceWise. Now I can open one project and I create a new project. Let me create this new project, this new trigger, and I will call it, I don't know, CNC data. I will say that this specific routine will run based on a schedule, and I want that this runs every half of a second. It could be in milliseconds, but let's put just half of a second. And I will start by saying, come here to my local database, do an insert, and I will define what type of input I will, what type of data I will retrieve from my device, as well as where I'm writing this. I'm gonna say, put this insert in my webinar table, collect this data from my CNC that I created there. First, my timestamp, sorry. So let me take my timestamp, uh, event time, when that happened, and I will tell, bring the data from my webinar CNC. When I say bring the data from my webinar CNC, I have here all the information, and I would just say, yeah, bring me the data from my access. Done. And I can just finish my trigger. I can validate, see if I didn't do anything wrong. Hopefully I did not. And I can start my trigger. Now, if I did all right, I can come and collect the data in my database. As you can see, I already have my inserts here, and I can see the data out of my database coming here. So every half of a second, device-wise, is going to my CNC, my Fanuc CNC, collecting this data in real time and feeding this database. That could be done in an external database, in a SQL, in an Oracle. This could be sending the data to my ERP system, to my MES system, or pushing the data from my MES system, writing it in the machine, starting machines, stopping machines, or doing everything that you can imagine that you could by having all your IT systems connected to all your machines. The last thing that I would like to show you is our ability to create real-time dashboards. So now that you have all your data flowing device-wise and you can do all your calculations, you also can create algorithms, math out of device-wise, I can create a real application here. I can create a new project that I'm gonna call it webinar, webinar, and webinar. Not a very creative name. Just created my dashboard. Oops, let me log in again. Hopefully my VPN is not gonna trick me. So let's do it again, webinar, webinar, and webinar. And I can simply drag and drop widgets. I can put a chart here. Okay, but it's not coming. Let me close that and open again. I'm doing something wrong here. And here I can just drag and drop my widgets, add my variable coming from device-wise, and say, bring this data from device-wise. And as you can see, all your widgets are coming in real time. You have many different types of widgets that you can add here, doing your performance calculation, doing all your different types of applications. So you have this data coming in real time from your devices, and this display can run in any type of browser. So you could even do this, a small application, for example, not only telling me what is the data that I'm bringing, but I also can create actions out of my displays. So let's see, I'm gonna put a button here and I'm gonna say call maintenance, and I can add triggers that will fire in device-wise, and then I can start creating actions by pushing this data in and on displays, using device-wise to send messages through email, SMS, opening tickets in SAP, or doing different types of applications. I can use this type of buttons also to create other types of applications, like let me use this to classify why I have a downtime. Maybe I have a downtime because of lack of raw material. And I can keep doing my displays by just changing the different types of widgets that I have. I have different color options that I can apply to here. I can add pictures, I can add videos. So this becomes a complete solution for your for you without the necessity of writing one single line of code. Guys, I hope that you liked what you saw.
The objective was just to introduce a little bit the concept of Industry 4.0 and how we are doing to really help our customers in this space. And I will be very happy to answer any question that you have. Thank you so much for watching.